Hi, good morning. Myself Dr. M. Saravanan, Professor and Head, Department of Civil Engineering. I am going to handle the subject Design of Steel Structures. So, subject code 22-601-33, 22 or 22 regulation, 6th semester, 01 Civil Engineering Code, 33 subject number. The title of the course is Design of Steel Structures. Prerequisites: strength of material, structural analysis, and reinforced cement concrete structures are the prerequisite for design of steel structures. So, syllabus of design of steel structures. In Unit 1, we can discuss about introduction to steel structures, merits and demerits, bolted connections. So, strength of the bolt, design of bolted connection we can discuss. In welded connections, strength of the weld and design of welded connections we are going to discuss. In Unit 2, design of laterally supported beam, design of laterally unsupported beam, and design of plate girder we can discuss. In Unit 3, we can discuss about the design of tension member and design of compression member. In Unit 4, we can discuss about the design of placings and battens. In Unit 5, we can discuss design of roof trusses and design of purlins. These are all the textbooks we are going to refer. S.K. Dugal, Limit State Design of Steel Structures. Bavikati, Design of Steel Structures by Limit State Method as per IS 800-2007. Subramanian N, Design of Steel Structures. These are all some references. Course objectives. The aim and objective of this subject is to make the students familiar with the behavior and design of the structural steel elements and their connections in accordance with the latest code of practice IS 800-2007 based on the limit state. Course outcomes. At the end of the course, the students will be able to design bolted and welded connections. They will be able to design of laterally supported and laterally unsupported beam and also the design of plate girders. You will be able to design tension member and design of compression member, and you will be able to design the lacings and patterns, and you will be able to design the roof trusses and purlin. So, if you want to design the structural steel elements, so not only steel structures, any kind of RCC, pre-stressed structures, earthquake resistant structures, whatever the type of structures if you want to design, there are some IS codes. We need to follow some Indian standard codes. So, as per this design of steel structures, you have to refer these codes. First one, general design and structural steel work. IS 800-1984 Code of Practice for General Construction in Steel, Working Stress Method. IS 800-2007 Code of Practice for General Construction in Steel, Limit State Method. Here you can see working stress method, it is uneconomical. That is the reason why now we are using the code IS 800-2007 Limit State Design Method. So, when we design the structural steel elements by using limit state design method, it will be economical. That is why we can follow the limit state method design code. So, this is the most important code for design of steel structure, that is IS 800-2007 Code of Practice for General Construction in Steel by using limit state method. Okay. IS 801 Code of Practice for Cold Formed Light Gauge Steel Structure, IS 802 Code of Practice for Structural Steel in Transmission Line Towers, IS 806 Code of Practice for use of steel tubes in general building constructions. And for steel material, we have some codes IS 2062, IS 961, IS 8500. And for steel sections, we have the code IS 808, IS 811. And for bolted, riveted and weldings. So generally structural steel are assembled, okay, connected by means of connections like bolts, rivets, welding. For that also we need to follow some codes like IS 3757, IS 4000, IS 8000, IS 9595. And for testing and properties, we have the codes IS 1608, IS 1599, IS 1757. For steel pipes and tubes, we have the codes IS 1239, IS 1161, IS 3589. And for corrosion protection, we can have code IS 2062, IS 4759. And for earthquake and special structures, IS 1893, Part 4, 2015. And also we have IS 15988 code. So these are all the few codes, but here mainly we are using the codes are IS 800 2007 code, and first few steel tables and all we are using for the know the properties of the steel sections. Now coming to introductions. So you know very well, highly loaded structures like long span structures, high-raised buildings, bridges, industrial structures, right, stadium. This type of heavily loaded structures are constructed by means of steel. So you can see in Howrah bridges in Kolkata, World Trade Center in USA, every high-raised structure, highly loaded structures are constructed by using the steel. Okay. So RCC also widely used structure. Reinforced cement, concrete and steel are major practice nowadays. So now we will see the difference between RCC structure and the steel structures. Reinforced cement, concrete and steel structures follow a similar load transfer method. Load transfer means generally you know what is the load transferring mechanism in the structure, isn't it? So generally load is transferred from the slab to the beam, beam to the column, column to the foundation, and then foundation to the earth. So this is the load carrying mechanism, either RCC structure, framed structure or steel framed structures. But they differ in several factors like material, construction, durability, etc. Now we can see the differences. As per material concern, in RCC structures, the basic material used is reinforced cement concrete to take up the load. In steel structure, steel is the material to take up the load. Durability, high durability. So RCC structure having high durability because less weather effect. But in case of steel structure, there is a less durability because of the high weather effect. You know well, steel structures are exposed in the atmosphere, exposed to other conditions. That's why because of the weather effect, steel structures affect more, so it has less durability. So we need to maintain properly steel structure to get the long life. Resistance to earthquake, RCC structure have highly brittle in nature. So if anything earthquake will happen suddenly, the RCC structure will fail here without any prior warning. But in steel structure, the steel material ductile in nature. So when earthquake load will come, at least we can have some time to save. So steel structures are ductile in nature. So compared to RCC, it may be good for earthquake resistance. And self weight, you can see RCC structure having high self weight. Whereas in the steel structure, when compared to RCC, it is less self weight. How means? Generally, in RCC structure, if you use 100 kg of RCC structure, it will carry only 100 kilonewton of load. But whereas in the steel structure, if you use 100 kg of steel, it can carry more than 100 kilonewton, maybe 1000 kilonewton also. So that's why minimum weight it can carry more load carrying capacity. That's the reason why the self weight will be increased when you use the RCC structure. But whereas in the steel structure, the self weight will be reduced. And coming to foundation, so since self weight is more, we need to provide the large foundation. Okay, heavy foundation we need. in the RCC structure. But in the case of steel structure, not demand any heavy foundations. And labor requirement. In RCC structure, you can see more labors are required, because in RCC structure there is a process of centering, form work, then curing. After removal of after concreting, we have to remove the form work. There is some time, days, as per the IS codes for the removal of shuttering and all. So labor required is more for RCC structure, whereas in the steel structure less labor required. And construction, RCC structure slow process, steel structure high process. In RCC structure, if you construct some G+10 building, means we need some 1 year, 2 year life period. But whereas in the steel structures, within 6 months they can able to construct a G+10 building. So fast construction will be possible in the case of steel structure. Fire resistance, you can see RCC structure having high fire resistance, but still the thermal conductivity of steel is more. Therefore, there is less fire resistance only in the steel structures. Any fire will happen, suppose consider G+10 building. If any fire will happen in the ground floor, in the steel structure, you can feel the heat in the 10th floor itself. But whereas in the RCC structure, the thermal conductivity is less, so we can't feel the fire in the 10th floor. So fire resistance is high in the case of RCC structures and less in the case of steel structures. And corrosion, in RCC structure less corrosion, but in steel structure, since it is exposed to weather, the corrosion is possible. High corrosion will be possible. Unskilled labors not required for construction of RCC structure, whereas in the steel structure we need skilled labors. Why? Because the major part in the construction of steel structure is connections, bolted, welded connections, and also technical persons is highly needed for construction of steel structures. Okay. So steel is one of the most widely used material in construction and manufacturing due to its excellent properties, versatility, and economic advantages. So it is an alloy made primarily of iron and carbon, along with other elements to enhance its strength, ductility, and resistance to corrosion. Generally, steel is manufactured by the combination of iron, that is more than 98%, and carbon, around 0.1 to 1.1% by mass, and other nickel, phosphorus, silica, cadmium, and chromium, etc. So a steel structure is an assemblage of group of elements expected to sustain their share of applied forces and to transfer them safely into the ground. Depending on the orientation of the member in the structure and its structural use, the member is subjected to forces either axial, bending, or torsion, or combination of this. Axial load can be either tensile or compressive, and accordingly the members are called tension member or compression member. So primarily all the steel structures are constructed with the elements such as tension member, that is member subjected to tensile force, compression member, member subjected to compressive force, and flexural member subjected to bending. Here you can see if the member subjected to two equal and opposite to pushing force, then this member is called compression member. If the member is subjected to two equal and opposite to pulling force, then it is called the tensile member. In structures also, in truss structures also, you can see the compression member and the tension member different. Generally tie member are called tension member in the truss structure. And flexural member, flexure means bending. Generally when the load is acting on the beam, because of the load, either point load or UDL, the beam is bending like this. So there is called flexural member. Okay. Member subjected to compressive force, compression member, member subjected to tensile force, tension member, member subjected to bending is called the flexural member. So the elements of a steel structure as discussed above are rolled to a basic cross section in a mill and worked to a desired size and form in a fabricating shop or site. These elements are connected by means of rivets, bolted or welded connections. The connections so formed are called the joints. So in the steel structures, connections are very important. Generally, bolted and welded connections are most important in the design of steel structures. So that and all we will see in the next lectures. Now we will see the applications of steel structures. So high-rise buildings, bridges, industrial structures, in transportation sectors, railways, airport and harbors, marine and offshore structures, energy sectors like wind turbine, transmission line towers and hydropower stations, sports and entertainment sectors like stadiums, indoor halls, exhibition halls, overhead water tank, chimneys, bunkers, silos, space frames, cranes, heavy equipments, and military applications like bunkers, storage tank, etc. We are using the steel structures. So you can see high-rise buildings, okay, constructed by means of steel. Okay, so as we discussed already, since steel has the high strength to weight ratio, the foundation cost, everything will be reduced, and it may be very economical when compared to RCC structure in case of high-rise structures. You can see the long span bridges, slender sections, long span bridges also constructed by using the steel, and heavily loaded industrial structures also constructed by using the steel. Transportation like railways, airport termination building, harbor, breakwaters, cranes, etc. Marine and offshore structures, energy structures like wind turbine, transmission line turbine, hydropower stations and all. Stadium you can see. So these are all constructed by using the steel structure, steel elements. Okay, now we can see the advantages of structural steel. So steel has high strength per unit weight of the material. So generally you can see in the concrete RCC structure, plain cement concrete. Okay, for concrete, the plain cement concrete density of concrete is 2500 kilogram per meter cube. 2400 kilogram per meter cube. In RCC, 2500 kilogram per meter cube. It means you can see in the characteristic compressive strength of the concrete for M25 grade of concrete, the compressive strength of the concrete is 25 Newton per mm square. Whereas in the steel, if you consider mild steel, the yield strength will be 250 Newton per mm square. So as I already discussed, so minimum weight, the load carrying capacity will be high in case of steel structures. Next, structural steel is highly ductile in nature. The ductility can be measured by determination of elongation, that is change in length by original length multiplied by 100. So when the elongation is less than 5% for the material, it is considered as brittle. When the elongation of the material is between 5 to 15%, it is considered as intermediate. When the elongation found to be more than 15%, then the material is called the ductile material. So I already told you the main property of the steel is ductility. The ductility means ability to deform without any failure. And steel is more economical when construction of long span structures, long span bridges and high floor constructions. And rapid construction is possible. And structural steel is tough. That is, they have both strength and ductility. And steel has uniform property as it is machine made. And structural steel is highly versatile, that is fasten different members together by connections. And structural steel is recyclable and it can be reused, that it is environmental friendly. And prefabrication of structural steel is easy, which results in the proper planning of construction, saving in time and money, speedy erection and better quality of finished structures. Structural steel members are gas and watertight because of its high density, and properly maintained steel structure have a long life. Easy repair, additions and alterations can be made easily in the steel structures, and high quality and reliability since factory production. That's why concrete have the factor of safety 1.5, but whereas in the steel it has 1.15. Now we can see the disadvantages of structural steel. Steel structures, when placed in exposed conditions, are subjected to corrosion. Therefore, they require frequent painting and maintenance. Steel has high thermal conductivity and fatigue. Fatigue means failure due to repetitive loads. And cost is high for small size structures. So these are all the few disadvantages of steel. Now we can see the types of steel. Steel can be classified based on its composition, application properties. Based on the carbon content, steel can be classified as low carbon steel, mild steel, medium carbon and high carbon steel. Low carbon steel 0.1 to 0.25 percentage by mass of steel. Ductility is high but less strength. Example, mild steel. Mild steel having 0.23 percentage of carbon content. The yield strength of mild steel is 250 megapascal. Medium carbon steel, the range of carbon content 0.25 to 0.6 percentage. Example, HYSD bars. HYSD means high yield strength deformed bars. Example, Fe415 and Fe500. This can be used for rails and steel tires. And high carbon steel ranges, carbon content ranges between 0.6 to 1.1 percentage. The example for high carbon steel, drilling machine, punching machine and steel hammers. And another type of steel is alloy steel, then stainless steel. Alloy steel used in construction equipment, machinery and high performance applications, and stainless steel used in kitchenware, medical instruments and architectural applications, and tool steel used in cutting tools, molds and dies, etc. And structural steel used in construction of building, bridges and other infrastructure. So generally for building and other infrastructural construction, structural steel is used. So structural steel is a category of steel construction material that is produced with a particular cross section or shape and some specified value of strength and chemical composition. Iron and carbon is the most important element in the structural steel. Carbon produces material with high strength and low ductility. The type of structural steel section normally used are beams, channel, flats, angles, etc. Physical properties of structural steel. The physical properties of structural steel can be referred from the IS 800 2007 class 2.2.4. The density of steel 7850 kilogram per meter cube. Young's modulus 2 into 10 power 5 Newton per mm square. Poisson ratio mu 0.3 in elastic range and 0.5 in plastic range. And modulus of elasticity 0.769 into 10 power 5 Newton per mm square. Coefficient of thermal expansion 12 into 10 power minus 6 per degree Celsius. And mechanical properties of structural steel. The important mechanical properties of structural steels are yield strength, ultimate strength, hardness, ductility and toughness. If carbon content increase, A, B, C will increase. That is yield strength, ultimate strength, hardness will be increased. And D and E, ductility, toughness will be decreased. Other mechanical properties of structural steel are Brinell hardness test and Wicker hardness test. Based on the hardness also we can know the strength of the steel. Yield strength is defined as it is nothing but the ratio of yield load divided by original cross-sectional area. Ultimate strength is defined as nothing but ultimate tensile load divided by original cross-sectional area. Ductility is nothing but the ability to deform without any significant loss of stiffness or strength. The ductility of the steel measured by using the percentage of elongation, that is change in length by original length, where the gauge length is 5.65 root of A0. A0 is the cross-sectional area of the specimen. And toughness is defined as the capacity to absorb energy. It is a measure of the ability of steel to resist fracture under impact loading. Right. So generally you can feel the impact load on bridges and structures subject to earthquake loads. So thank you. These are all the textbook and references you need to follow for studying this structural steel. Okay. So thank you so much.